Good morning, everyone, and thank you very much for joining the Stormlands Academy. Now, today we're going to look at the introduction to the Newton's law. We're going to outline the following. We're going to define a force. We'll look at the types of forces, and then discuss them one by one. Then, as well as the Newton's first, second, and third law. Now, what is a force? A force is any kind of push or pull on an object in an attempt to change the object state of rest or motion. The force has a symbol of F, and its SI unit is in newtons. Now, a force has a magnitude and direction, and therefore it is a vector quantity. The important notice about a force, what you need to take down here is that when a force is applied, there are also two objects that are involved, and these objects interact with each other. They can be in contact with each other, or they can interact with each other without being in contact with each other. And now let's look at the types of forces. We have two types of forces, which are contact forces and the non-contact forces. Now let's look at contact forces. These forces are forces that touch each other when exerted on an object, and these forces are four. We're going to look at them one by one. Applied force, normal force, frictional force, and the static force. Now let's look at applied force. This is a force that is externally exerted on an object, e.g. the push or pull or force. Looking at the diagram here, you can see the other person in the left is pushing, and the other person in the right is pulling. And then the force from the engine can also be classified as a applied force. Now the normal force, this is the force which is exerted by the surface on an object, and this force is always perpendicular to the surface. Now, normal force, what you need to know about the normal force is that it's equal to the gravitational force, or the F net of gravitational force, and all other forces that are acting on the surface. That's your normal force, is the one that is going up there. And then you have your 20 kg box with the normal force of about 196 newtons. Now to get if you know your normal force, automatically you know your force of gravity there, because they are equal. Number 3, your frictional force, the Fg. This is the force that opposes the motion of an object and resists the movement of that very object. It is always parallel to the surface, but in the opposite direction to a moving object. Now, looking at the diagram here, your frictional force is going to the left, opposing the direction of motion, which is going to the right. And then you can also see your object on an inclined surface here. Your force of friction is actually the object is going down. Your force of friction is actually resisting the movement in the opposite direction. Number 4, your static frictional force. Now, an object that is not being set in motion by any forces acting on it by pushing or pulling, it experiences a static frictional force. This is the force that is just there when the object is static, is not moving or anything. Now, the static force is equal to the force applied in magnitude. They are equal in magnitude. Now, let's look at the force and the free body diagram. This is very important to differentiate the two, the force and the free body diagram. Both force and the free body diagram indicate the relative magnitude and direction of all forces that act on a body. This is the similarity for both of them. Their function is to actually show all the forces and their direction on a or a body, on an object. Now let's look at the force diagram. We're looking at the force diagram. The force diagram is the object of interest is drawn, and all the forces to and from the object are indicated by arrows. The arrows forces are pointing in the direction of the force. For example, looking at your normal force there, it's actually pointing in the direction of the force is applied perpendicular to the ground, and then your applied force is applied there. It goes to the right. The arrow is pointing into the right. This is the direction at which the force is applied. Now you have your force of friction here. Your force of friction is applied in the opposite direction to the force applied. You can see your arrow pointing in the left direction here, and your Fg, which is the gravitational force, pointing downwards here. The arrow is pointing downwards. Now the force arrows are pointing in the direction of the force. This is your force diagram. So in the exam, you can be given a scenario and then they say draw a force diagram. A force diagram, this is what you're going to actually present. And then let's look at the free body diagram. In case of the free body diagram, an object is represented by a dot, and all the forces that act on the object are indicated by arrows pointing away from the dot. Now the dot here represents the object, and all the forces that act on the object are actually moving away from the object. They are pointing away from the object. You look at your normal force here pointing upwards. You look at your force applied pointing to the right there, your force of friction pointing to the left, and your Fg pointing down. The difference between the two is that the other one is represented by a dot and the arrows pointing away from the dot in case of the free body diagram, but in case of the force diagram, the arrows actually point in the same direction as the force. I hope you do understand up to this far. Let's move forward. Now we're going to look at the resultant or rather the net force. When more than one force acts on an object, the resultant or the net force is determined by adding up all the forces and their components in the same direction by means of a vector. What it means here is that all the components in the y-axis are going to be added together, and all the components in the x-axis are going to be added together, and that's your resultant force. It's actually all the forces and their components acting on the object. It's called a resultant force or net force. Let's move forward. Now, forces in one direction on an object at rest or an object that is moving. Now we have the horizontal. In terms of the horizontal object, that these are objects that are being pushed or pulled over a horizontal surface. They are actually on the floor horizontally. So vertical, we're looking at the object that move vertically through the air, or these objects are suspended from a cable, e.g. you have your elevator there. Now the illustration below, if when you have time, just visit this illustration here. I'll just do the touch-ups here. You see your force number one, in terms of your free body diagram, it's a dot here, and then force number one, we have only three forces acting on the force, because it's horizontal. We have the normal, we have the gravity, and the force applied. And then when two or more forces are applied, we're looking at all your forces acting there. You see your force applied, you see your normal force, your Fg, and then your force of friction this side, and all that. And then we also have a scenario whereby the force at an angle relative to the horizontal. You see, this is your component, your y axis, and then your x-axis. This is your component, which is the applied force. And then you look at the resultant here. The F net is going to be, in this case, is going to be F net is equals to force applied, but in this case the F net is going to be equals to F2 plus frictional force and your force applied force. And then in this case your F net is equals to Fx. Fx is the component of the x-axis, and then you have your Fa is equals to cos the angle of the angle between the surface and the force applied there, and then you have your thing there. And then just look at the diagram with understanding when you have time. Now we're going to look at the Newton first law. Newton first law. It states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless acted upon by a force. Meaning that if an object is at rest, it will remain at rest, and if an object is in motion, it will remain in motion at the same velocity. I hope you do understand your Newton first law there. And then let's look at the Newton second law. Newton's second law states that the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Now in this case, what it means is that an object will remain at rest unless the force is applied on it. And then, well, what you should know about the Newton's second law, what is very important, is this formula here. This is to say, now the bigger the mass, the more, or rather less velocity it's going to result. And you have it there. Look at the diagrams very closely. You have a diagram whereby each force is acting on the system and to produce a net force. So look at the bodies as well and understand them. In terms of Newton's third law, it states that whenever an object exerts a force on a second object, the second object exerts an equal force but in the opposite direction to the first object there. For example, you have your somebody there nailing the hammering the nail, and then the nail actually brings the same force in the opposite direction. This is the force applied by the hammer here, pounding the nail inside, and then this is the force applied by the nail in the opposite direction, exerting to the your hammer there. That's your Newton third law. You've done this in grade 10. This is just revision. And what you need to understand again about your Newton third law there is that for example, if you are pushing a wall, the wall is not moving. What you should understand is that it's not moving because it's exerting the same force to you but in the opposite direction. Should you be able to move the wall, it means now the force that you are applying on the wall is actually greater than that which is exerting back to you. I hope you do understand all that, and thank you very much for watching the Stormlands TV. We have come to the end of our session, and then please don't forget to subscribe to our YouTube channel for more academic videos, or rather or PowerPoint audios like this. I hope you find this very helpful, and it's our duty to make sure that you are provided with all these things. Just subscribe for more and then support. Thanks very much. Until we meet again.